5. Today we're going to continue our review of previously learned material by taking a look at domain, range, and what is or is not a function. Now, the summary version of what we're doing today is domain is a list of all the x's that are included in my function. Range is a list of all my y's included in my function. And we define something as a function if it has no repeating x values or it passes what we call the vertical line test, which people commonly call the pencil test, meaning I can't touch it more than twice if I run my pencil across it straight up and down. So let's go ahead and jump into it. So a function is a relation in which no x value is paired with more than one y value. Do not repeat x's. So, for example, if I was to look at these ordered sets, a list of points, I would only look at the x's. I don't care about the y's. I'm looking at it and I'm looking to see if I see any repeats. No repeats over here. This is a function. Over here, however, they repeated the 0. This is not a function. So the ordered set on the left is a function because it has no repeating x's. And the ordered set on the right is not a function because x equals 0 repeats. Now, what about mappings? Well, all I have to do is focus in on those x's. I'm looking to see if any one of them has more than one line. And I see right here, this 4 has 2. This is not a function. Over here, however, each x has its own separate line. This is definitely a function. So the mapping on the right is a function because it has no repeating x's. And the mapping on the left is not a function because x equals 4 repeats. It goes to 5 and negative 5. Now, we can also use, as I mentioned earlier, the vertical line test. Sometimes you will hear people call this the pencil test. That's the usual name for it. But the official super fancy name is vertical line test, and I think I spelled vertical right. So, the way that you do this, I want you guys just to imagine that this is a pencil. Take your pencil, run it across your graph like this. You're looking to see if it will ever touch more than one time. It does not. Therefore, function. And I'm going to do the same thing over here. And look at that. It touches twice lots of times. Not a function. So the graph on the left is a function because it passed my vertical line test. However, the one on the right is not a function because it failed my vertical line test. Now, as I mentioned earlier, my domain is a set of all possible x values of a function. Sometimes people use other words for it. As we've learned many, many times before, math people love to make things very difficult by naming them all kinds of different things. So we can also call this x values, my input, and my independent variable. Now, what about my range? This is a set of all possible y values. Other names are going to be y values, output, and dependent variables. Now, continuous functions are those that are completely connected. Meaning I can connect all of them. They're not separate points. There are no gaps or holes. And we use the special type of notation called interval, meaning we're going to use those inequality symbols. Okay? Now, of course, there's a couple of different things that we can use with this. So, for example, if I'm looking at this and I see a dot that is filled in, I would say that that is included. So it's going to have one of these symbols if it's included in my domain or range. However, if my dot is not filled in, it's not going to have the extra line. Now, discrete functions, on the other hand, are separate and unconnected values. So examples of these might be mappings, tables, and ordered sets. And we use set notation, meaning we have to list them all out. So for example, if I looked at this mapping, first thing I would say is, this is discrete. These points are not connected to each other. They're not on a graph. My domain is going to be listed out as -7, 0, +4. My range is going to be listed out as -5, 0, 3, and what appears to be a 9. That's it. Pretty simple. Remembering that these guys are always going to be in alphabetical order. It's always going to be X before Y. Now, what about these continuous graphs? I see that they're all connected, so it's got to be continuous. My domain and my range, the easiest way to find it is to think of them as limits. These are limits. This is how far left, how far right, how far down, how far up. So the first thing that I want to do is I'm going to highlight my domain axis, highlight my range axis. I'm going to go ahead and I'm going to take my pencil, a Post-it note, a piece of paper, a ruler, anything I want. And I'm going to go ahead and place it here. I'm going to get my domain and my range set up. Meaning I always start with this. Both of them are always going to have this. I'm going to grab my pencil. I'm going to start way out here. I'm going to move in towards my graph. And at the very first point that I touch is equal to -2 on the x-axis. And I look at the dot. I see it's filled in. I put an extra line. Now I'm going to grab whatever my object is, and I'm going to look at the very furthest right. The very first point that I encounter is here at +4. I'm going to write that in. However, it is not filled in, so I do not put my extra line. My domain is now done. Now, my range, on the other hand, what I'm going to do first is I'm going to go ahead and I'm going to shift whatever object I'm using, my ruler, my pencil, and I'm going to go to the very bottom, the lowest point I can find. So I'm going up, 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 up. I encounter my graph. I see the lowest point is located at y = -3. It's filled in, extra line. Now I look for the highest point, located at y = +3, not filled in, no extra line. Now, I do want to make sure, even though we're done with this, I want you guys to understand something. It does not matter if this graph instead looked like this. It would still have exactly the same domain and range. It could look exactly like what I just drew, and it would still have the same domain and range. Why? Well, because it goes the same distance out here, same distance down here, same distance over here, same distance over here. It is still inside of essentially what you can view as a box. Same domain and range. So don't get caught up on what kind of graph it is, okay? All that matters is how far left, how far right, how far down, how far up. Okay? So I want you guys to actually I have one more point. I did want to include this here. So if you see an arrow, you're always going to use those symbols, and it's either going to be a positive infinity or a negative infinity, but you do not necessarily write them. Sometimes people don't include them. Okay? So I want you guys to go ahead and get started on your example questions, and I will see you next time.